Thank you for having the paper on the program. It's great to be here. So let me start with the motivations for this paper. So there is by now quite a lot of evidence showing that firm level markups are variable. So for instance, there is evidence that markups respond to trade liberalization, they vary with exchange rates, with per capita income, etc. But surprisingly, there is no evidence of how the markups of exporters vary across destinations depending on trade costs, such as bilateral distance or tariffs. And also there is no evidence of how product quality shapes the response of markups to changes in trade costs. So our contribution in this paper is to show that the markups of exporters increase with distance, they fall with tariffs, but we also show that these effects are actually smaller for higher quality exports. So our findings also contribute to understanding a robust finding, which is typically found in the literature, which is that firms tend to set higher prices when they export to more distant countries. And usually this positive effect of distance on export prices is explained by a larger share of higher quality and therefore more expensive goods being exported to more distant countries. So this could be due to a composition effect, due, for instance, to per unit trade costs, as suggested by Algen and Allen, or it could also be due to a selection effect where firms simply choose to export higher quality goods to more distant countries. Here, instead, what we provide evidence for is for an alternative mechanism, which is simply that conditional on quality, exporters price discriminate, and they're going to set higher markups and therefore higher prices when they export to more distant countries. But in addition, we also show that this effect is going to be heterogeneous and smaller in magnitude for higher quality exports. So first, to motivate our empirical specifications, what we do is to rely on the model of Martin, so the model is quite standard because we have monopolistic competition and CES demand, but the model assumes that trade costs are both ad valorem, so iceberg, as well as per unit, like an additive cost. And the advantage here is that by allowing for per unit trade costs, we can generate variable markups that depend on trade costs. So what the model predicts is that for a given quality, export prices and markups are going to depend positively on per unit trade costs, which can be proxied for by using bilateral distance. And they're going to depend negatively on ad valorem trade costs or tariffs. And then what the model also predicts is that the magnitude of the effects of trade costs, so both distance and tariffs, is going to be smaller in magnitude for higher quality goods. So there's going to be some heterogeneity across different goods with different qualities. Then what we do is to bring the predictions to the data, and we use a data set of firm level exports of Argentinian wines between 2002 to 2009. And the main advantage of the data set is its level of disaggregation, because for each wine exported, we observe its name, its type, so we have whether it is red, white, or rosé. We have the grape and the vintage year. So it means that we have basically data at the individual product level. And then what we do is to combine this trade data with experts' wine ratings as a measure of quality. And we use two different ratings, so the Wine Spectator and Parker. And in both cases, the quality ratings are defined according to the name, the type, the grape, and the vintage year of each wine. So we can easily match this data on quality to the trade data. So for our purposes, the data offers several advantages, because the first is that given that we have data on individual products, this means that we can compare the unit values of a given wine exported by a given producer at a given point in time across destinations, holding the quality of each wine constant. And also in our analysis, we only focus on wine producers. So we exclude wholesalers and retailers, which are actually very few in the data. And this means that each wine is only exported by one firm. So each product is going to be firm specific. The second advantage is that when we explain export prices, we can identify the variation in markups by including product time fixed effects, where the product time fixed effects are also firm specific. And this means that once we include the product time fixed effects, we can compare the unit values of a given wine that is exported to more than one destination in each time period. And therefore, given that marginal costs do not vary across destinations, this means that the variation in export prices across destinations has to capture the variation in the markup. And finally, the last advantage is that we have an external measure of quality so that we can look at how firms set their unit values and markups across destinations, depending on the quality that they export. Okay. So what we find, so first we find that when we just look at, when we try to explain the variation in export unit values, we find consistent with previous literature that unit values tend to increase with distance and to fall with tariffs. But this effect, when we look at export unit values, this effect could be due to composition, to selection, or to variable markups. We don't really know. Then what we show is that these effects can be explained by variable markups. So this is once we include the product time fixed effects. And we find that markups increase with distance and fall with tariffs. Now, in terms of quantitative effects, what we find is that markups, variable markups, can explain up to half of the effect of distance on the variation in within firm unit values across destinations, while markups explain around 3/4 of the effect of tariffs on the variation in within firm unit values, while the rest is actually due to selection or to composition effects across products within firms. So basically, when we include the product time fixed effects, we control for selection and composition effects because we eliminate all the wines that are exported only to one destination in each time period. And finally, what we also find is that the effects of trade costs are heterogeneous and they tend to be smaller in magnitude for higher quality exports. So the model, as I said, is based on Martin. So what we do is to define trade costs, TIJ. So this is the trade cost of a monopolistically competitive firm I exporting to country J, simply as the difference between the CIF and the FOB price. And this is given, so tau, this is the ad valorem cost, the iceberg cost minus 1 times the FOB price, plus some per unit cost or additive cost. Then we can rewrite the relationship between the two different prices, as in here, where now what we introduce is that the two prices depend on CI of theta, and this is the marginal cost of firm I, and we assume that the marginal cost increases with quality theta. So here we assume that quality is exogenous. However, we assume that producing a higher quality means higher marginal cost because producing a higher quality entails that you need higher quality and therefore more expensive inputs. Then the firms, so this is pretty standard, the firm simply maximizes profits subject to a CS demand. So we get the CIF price, and from this we can extract the export price, so the FOB price. So here what you can see is that, so a higher quality theta means a higher marginal cost, so higher quality has a higher export price. Now in the standard case where there is no per unit trade cost, so TIJ is equal to 0, we have the standard result that the price is simply a constant markup over marginal costs, which means that both prices and markups do not depend on trade costs. Instead, once we have the per unit trade cost here, what we can see is that now for a given quality, both the price and the markup are going to increase with the per unit cost, and they're going to decrease with ad valorem costs. So now what we're going to have is that the price and the markup are going to vary with trade costs. So now what we want to do is to derive the elasticities of the FOB price and of the markup with respect to bilateral distance and tariffs. So first for bilateral distance, so evidence shows that per unit trade costs tend to increase with distance. So what we do is that we calculate the elasticity of the price and markup mu with respect to the per unit cost as a proxy for the elasticity with respect to bilateral distance. So when we calculate this elasticity, we get this expression here. So the two elasticities are the same because the marginal cost does not vary across destinations. So what you can see here is that the elasticity of the price and markup with respect to the per unit cost and therefore to bilateral distance is positive. But as a higher quality means a higher marginal cost, this means that the magnitude of this elasticity decreases with quality. Okay? So empirically, what we would expect is that when we explain export prices or markups, we would expect the coefficient on distance to be positive, while the coefficient on the interaction between distance and quality should be negative, so that we have a smaller effect for higher quality exports. Now we do the same for tariffs. So here what we do is to calculate the elasticity with respect to the ad valorem trade cost. Now we get that this elasticity is negative. So the FOB price and the markup decrease with tariffs. But again, what we have is that a higher quality means that the magnitude of this elasticity is going to be smaller. And therefore the magnitude, so the second part of the prediction is that the magnitude of the elasticity to the ad valorem trade cost decreases with quality. So empirically here we expect the coefficient on tariffs to be negative, while the coefficient on the interaction between tariffs and quality should be positive, such that we have a smaller effect for higher quality exports. So here the predictions that we get, we obtained them because of the introduction of the per unit trade cost in the model. And this is because the per unit trade cost generates an elasticity of demand to the FOB price that depends on trade costs and quality. So here we can write the elasticity of demand to the FOB price. Here is the elasticity to the CIF price, and then we have this term here. Okay. Here we simply replace the FOB price by its expression. So what you can see is that if there is no per unit trade cost, then the two elasticities are the same, and they're just equal to minus sigma. Instead, once you have a per unit trade cost, what we can show is that the elasticity of EFOB with respect to the per unit trade cost is going to be negative, and it is going to increase with the FOB price, and therefore it is going to increase with quality. So this means that the demand is going to be less elastic in more distant countries, and therefore exporters will find it profitable to increase their prices in order to compensate for the lower demand they face because they face higher transportation costs. So this means that prices will increase with distance, but they will increase by less for higher quality exports. Conversely, what we can show is that the elasticity of EFOB with respect to the iceberg cost is positive, and it falls with quality. So in this case, we will have that prices are going to fall in high tariff countries, but also by less for higher quality exports. So this is what is driving our predictions in the model. So here we use CES preferences, but we can also show that we can get similar predictions if we use non-CES preferences. So what we can show is that we can generate similar predictions if we use translog preferences or additively quasi-separable utility. Instead, if we use a quadratic non-separable utility, we can derive some, but not all of our predictions. Okay, so our predictions are not limited to CES, but they don't hold with all of the different types of preferences. Okay, so now let me go to the data. So we use a data set of Argentinian firm level exports of wine, and we observe the name of the exporting firm, the destination country. We have the date of shipment, so this is transaction level data, but we aggregate the data at quarterly frequency. And then we define a wine depending on its name, its type, its grape, and its vintage year. But given that prices and markups could also vary depending on the container type, we define a product also assuming we take into account what is the type of container that is used for shipping. We have the FOB value in dollars, the volume in liters. We calculate unit values. Each wine is exported only by one producer, so each product is firm specific. And we assume, we consider that our unit values can plausibly be interpreted as prices given the level of disaggregation of the data. Then for quality, we use two experts wine ratings to measure quality. So as I said before, the quality is available for each wine depending on its name, grape type, and vintage year. In the two cases here, we have that quality varies between 50 and 100. A higher value indicates a higher quality. And then what we do is to merge these quality ratings with the exports data. So if we use the wine spectator, we have 237 firms, 8,000 wines, which corresponds to more than 11,000 products. Quality varies between 55 and 97, so there is quite a bit of variation in quality. And this represents about 41% of total exports over the period. The coverage with the Parker ratings is not as good. So basically we use the wine spectator ratings for our main specifications. So to test the predictions, what we do is to estimate the unit value of each wine product K exported from firm I to country J in quarter T. We regress this on distance and tariffs. We also control some other country level characteristics like GDP, GDP per capita, and remoteness. And then what we do is to interact distance and tariffs with quality. Okay. So we expect export prices and markups to increase with distance, but by less for higher quality goods. So we expect alpha 2 to be negative. And we expect them to decrease with tariffs, but again by less for higher quality goods, so that alpha 4 should be positive. And here we include the product time fixed effects, which allows us to identify the variation in markups. Then what we do is to proceed with a more stringent specification where we further include firm destination time fixed effects, in which case we can only estimate the two coefficients on the interaction terms that capture the heterogeneity across quality levels. So these are the main specifications. First, I'm going to show you results where we do not include the interaction terms with quality. So we just look at the direct effect of distance and tariffs on prices and markups. And also I will first include firm time fixed effects such that we're going to look at the effect on the variation in export prices rather than markups. And then we will move on to the specification with the product time fixed effect. So here the first column, so we have firm time fixed effects. So firm time fixed effects will look at the variation in prices. And we have that export prices or unit values increase with distance and fall with tariffs. Then when we control for quality, we have that higher quality exports are more expensive, but again, export unit values increase with distance and fall with tariffs. And when we include the product time fixed effects, now we can identify the variation in markups. And we find that markups increase with distance and fall with tariffs. Now, if you compare these magnitudes here relative to what we have in column 2, what you can see is that markups explain around half of the effect of distance on the variation in export unit values, while markups explain around 3/4 of the effect of tariffs on export unit values. Then in this table, now we look at heterogeneity. So what we do is to interact distance and tariffs with quality. And we find that markups increase with distance, but by less for higher quality goods. They fall with tariffs, but also by less for higher quality goods. And the results remain similar so the coefficients on the interaction terms remain similar once we further include firm destination time fixed effects. So, based on the regression in column 1 here, what we can do is to plot the distance and tariff elasticities at each quality level in our sample. So this is what we get here. So horizontal axis, we have quality, varies between 55 and 97. So you can see that the distance elasticity is large for low quality levels and is positive, and it becomes much smaller at higher quality levels, while the tariff elasticity is negative and large for low quality levels and becomes much smaller in magnitude at higher quality levels. Okay, so then what we do in the paper is also to try to ensure that our results are not driven by alternative mechanisms. And the first mechanism we try to control for is the degree of competition in foreign markets. So in the model, the sigma, the elasticity of substitution, is constant, but it affects the elasticity of the markup to distance and tariffs. So what we do is to estimate the elasticity of substitution by quality bin and by destination. And whether we estimate by quality or quality and country, we find that the elasticity of substitution tends to be lower for higher quality exports, which means that higher quality exports face less competition in foreign markets. And then what we do is to rerun our regressions, but we further interact distance and tariffs with the elasticity to make sure that our results are not driven by the sigma. And the results remain similar. We also try to control for other country level characteristics, but maybe I will just skip this here because due to time constraints. We also have extensions. We find that heterogeneity is stronger for exports to richer countries. It is also stronger for the high performance firms. We also look at other manufacturing industries and the predictions for export volumes. So we have lots of robustness checks that I'm just going to skip. And so we'll go directly to the conclusion. So what we do in the paper is to show that the markups of exporters vary across destination depending on trade costs. The effects are heterogeneous and smaller for higher quality exports. And we believe that this is important because it shows that the variation in firm level export unit values across markets is not only driven by quality differences, but also by markup variation conditional on quality. Trade costs generate deviations from the law of one price, and the results are driven by the high performance firms, which means that there should be some implications from a macroeconomic point of view. Then the framework militates in favor of models featuring variable markups that vary across countries, and also stresses the importance of allowing for different types of trade costs, like per unit trade costs, because this allows us to explain some strong patterns that we observe in the data. Okay, so I think I'll stop here. I don't know if I'm over time or not.
You're more or less fine, Natalie.
Okay,
perfect.
perfect. Thank you.
I got two questions from Rita Brata-Bose. She's asking, well, actually a couple of questions, but is there any inventory cost of storing wines by the producers? So whether export activities continues or takes place in lumpy ways, and if each wine is exported by each producer, whether there is any self-selection of producer based on the distance from Argentina to destination countries. And then Harald, I've seen that you want to, you have requested the floor, but let me first, Natalie, if you want to reply to these two questions.
So yes, there are some inventory costs. Also, when we look at the vintage year of the different wines that we have in the data set, I think the vintage year varies from 1977 up to 2009. So obviously there's going to be some storage costs, but this should be controlled for when we include the product time fixed effects. So this should be controlled for. Then the other question was about the selection.
Yes, selection on distance, basically, whether you know that someone is exporting far away versus.
So we in one of the appendices we try to control for selection, and to run a selection kind of three-step methodology with a Heckman procedure in order to try to control for selection. The magnitude of the coefficient is slightly smaller, but qualitatively there's not much difference, basically. Yes, we try to address this.
Harald?
Oh, yes, very nice paper, Natalie. So I was thinking whether the degree of competition in the destination market is also key. So is it really monopolistic competition, or is this oligopoly with pricing to the market? Wouldn't a more standard formulation of trade costs together with a different assumption on the competition in the product market also do some of the job?
So So you mentioned pricing to market as well as the degree of competition. So these are two things that we try to control for separately. So first there is the elasticity, but then separately we also try to control for pricing to market by including an interaction between exchange rates and quality. But we haven't tried to do the two of them at the same time. So that's something that we could also try. We just did one by one, but the results remain very similar if we control for whether it is pricing to market or competition in the sigma. I mean, we try to control for the degree of competition. We also try to control for the degree of import competition by controlling for what is the share of imports of each country from Argentina in wine relative to other countries. But it didn't make any much difference.